Here are the answers for the review worksheet about monomials and polynomials. The directions are simplify for every question on this worksheet. Question 1. The dot in the middle tells us this is a multiplication problem, so let's take a look at what's being multiplied. 2m to the second power is a monomial. It has a coefficient 2 and a variable, the m to the second power. It's being multiplied by this other monomial, 2m to the third power. To multiply monomials, multiply the coefficients first. 2 times 2 is 4. Then multiplies the variables. M to the second power times m to the third power is m to the fifth power. To multiply variables, you add the exponents. Now number 2. There's multiplication in the middle. This is a monomial, and this is a monomial. Multiply the coefficients first. 1 times 2 is 2. Then multiply the variables by adding the exponents. 4 add negative 3 is a 1. Because the exponent is a 1, you don't even really need to write that. You can say 2m. Now question 3. There's multiplication, and the things being multiplied are monomials. Multiply the coefficients first, 8, and then multiply the variables by adding the exponents. Negative 3 add 2 is negative 1. Number 4, same structure. 4 times 2 is 8, and multiply the variables by adding the exponents to the 1. And for this one, you can just say 8n. Okay, now number 11 changes the structure. This time we're not multiplying monomials together. What we have is a power, specifically x to the second power, and that power is being raised to another power. This structure is called a power to a power. To raise a power to a power, you multiply the exponents. So the answer is x to the 2 times 0, which is x to the 0 power. Now, I can't remember in what lesson we learned that any number raised to the 0 power is equal to 1. So this is then, in turn, equal to 1. I just can't remember if we're supposed to do that yet. If not, then the answer is x to the 0 power. Okay, number 12. This time, there is a product. The product contains the coefficient 2 and the variable x to the second power. That product is being raised to a power. So this type of problem is called a power of a product. To find a power of a product, you raise each factor of the product to the power. Start with the coefficient, the 2, and raise it to the power, negative 4. Then move over to the variable factor, x to the second power, and raise it to the power of negative 4 by using the rule from the previous question where you multiply the exponents. 2 times negative 4 is negative 8. Finally, to simplify this, the part that actually has a number, the coefficient part, 2 to the negative 4 can be typed on a calculator, and that is 1/16. And that can be written next to the x to the negative 8. Now question 13. Which structure is it? Is it the very first thing where you're multiplying monomials? No, it's not. Is it the power raised to a power? Nope. It is a product being raised to a power. So think about how you perform simplifying with this structure. You raise each factor in the product to the power. Start with the coefficient. Take the 4 and raise it to the 4th power. Then move over to the variable r and multiply the exponents. 0 times 4 is 0. 4 to the 4th power is 256. R to the 0. Again, r to the 0 power is equal to 1, and so this is really just 256. I just can't remember when we learn in Algebra 1 to know that r to the 0 power equals 1. Okay, number 14. This is a product. The coefficient is 4. The variable part is a to the 3rd. That product is being raised to a power. So think about structure. It always comes down to structure so that you know which rule to apply. To raise a product to a power, start with the coefficient 4 and raise it to the power, 4 to the 2nd power. Then do the variable, a to the 6th power. 4 to the 2nd power is 16, a to the 6th power. Number 1, what's the structure? What do we have going on? There is a polynomial, and it's being added to a polynomial. This is not a multiplication structure. This is adding polynomials. So you got to think about that structure and how you simplify. You add polynomials by adding like terms. 5p squared, add 2p squared. Add the coefficients, 7, and keep the variable name p squared. There's also a minus 3 and no constant term to combine with it, so there's a minus 3 in the answer. And then there is the negative 3p cubed. Negative 3p cubed. Now you can record your answer like this, or you can practice putting them in order of decreasing degree, which is what you're going to have to do later in the school year. So negative 3p to the 3rd power is written first. It has the highest degree, that is the highest exponent. And then the positive 7p squared. And then finally the minus 3. Okay, question 2. Look at the structure. This is a polynomial with 2 terms called a binomial. This is a polynomial with 2 terms. It's called a binomial as well. And what are we doing? Are we adding? Are we subtracting? Are we multiplying? What are we doing? This is subtraction. To subtract polynomials, you subtract like terms. Here is a to the 3rd power. In front of that a to the 3rd power, think of it as being one of them. We're subtracting negative 4a to the 3rd power. Focus on the coefficients. We have a 1, and we're subtracting a negative 4. That makes 5. And that 5 is the coefficient of the a to the 3rd power. Now there's also terms that have a to the 2nd power. So here is negative 2a to the 2nd power, and we're subtracting 3a to the 2nd power. Focus on the coefficients. There's a negative 2, and we're subtracting a 3. That's negative 5. And that negative 5 was the coefficient of a to the 2nd power. Question 3. There's a polynomial and another polynomial, and the operation is adding them. Add like terms. There is a 4, and later on a 2. 4 plus 2 makes 6. There is a 2n to the 3rd power and a 5n to the 3rd power. Adding those together, that's 7n to the 3rd power. Again, if you want to, you can put it in order of decreasing degree. So the 7n to the 3rd power is written first, and then the positive 6. Okay, question 4. There's a polynomial, another polynomial over here, and subtraction. To subtract polynomials, you subtract the like terms. 4n, subtract 4n. That makes 0, 0n. I'm not even going to write that. Now let's look at the terms that have n cubed. This is negative 3n cubed, subtract 3n cubed. Focus on the coefficients of the n cubed. Negative 3, subtract a 3. That's negative 6. And that negative 6 was with the n cubed. So it's negative 6 n cubed. Number 11, there is a polynomial with 3 terms called a trinomial. Over here, there's another polynomial that has 3 terms. That's a trinomial. And the operation is subtraction. Subtract the like terms. Here's 12a to the 5th power. Subtract negative 2a to the 5th power. Let's focus on the coefficients. That's what we're subtracting. The 12, and we're subtracting the negative 2. That's 14. And that 14 was the coefficient of a to the 5th power. Now the next term is negative 6a. In the other parentheses, there's a 10a. Those are like terms. So negative 6, subtract a 10. That's negative 16. And so negative 16a. Right here, there is a term with a cubed. And in the other parentheses, there is no term with a cubed. So there's nothing to combine with this. This is negative 10 a cubed. There's one more term, and it's over here on the end. It's an a to the 4th power term. Now we have to be really careful to not lose sight of the fact that we're subtracting. We're subtracting negative 14a to the 4th. Negative times negative is positive 14a to the 4th power. Now you can leave your answer like this, but thinking ahead in class, you need to get in the habit of putting it in order of decreasing degree. 14a to the 5th power comes first, then the 14a to the 4th power, then the negative 10a cubed, and then the negative 16a. Now question 12. There is a polynomial, specifically a trinomial, and another polynomial, and we're subtracting. So this time, so that I don't have to rewrite my answer in order of decreasing degree, I'm going to intentionally start with the highest degree term that I can find. That's an n to the 4th power term. So here we have negative 3 n to the 4th power. And in the other polynomial, the 11 n to the 4th power, remember we're subtracting. Our coefficients are negative 3, and we're subtracting the positive 11. That's negative 14. So in our answer, negative 14 n to the 4th power. Now, what's the next term by degree? That would be the n to the 2nd power terms. So here we have 10 n to the 2nd power, and over here, a 3 n to the 2nd power. Remember that we're subtracting. 10 subtract the 3. That's 7. So in my final answer, I have a positive 7 n to the 2nd power. Now our next term in order of decreasing degree would be to just have an n. And here there is one, 8n. And there's no n term over here to subtract from it, so positive 8n. Last is our constant term, right over here, the negative 7. But remember, in the middle, this subtraction, we're subtracting the negative 7. That makes plus 7. Question 1. Now the structure changes again. Here we have a monomial. And this monomial is being multiplied to a polynomial, or specifically a binomial, but it's a polynomial. It has more than one term. To do this, you use the distributive property. Distributive property is where you take the monomial and multiply it to the first term in the polynomial, and then again to the second term in the polynomial. 6v multiplied to the 2v, and then again 6v multiplied to the positive 3. 6 times 2 is 12. V times v is v to the second power. 6 times 3 is 18, and there's a v. Number 2 has the same structure. You take the 7, multiply it to the first term, and then again to the second term. So writing it out, the 7 gets multiplied to the negative 5v. And then the 7 gets multiplied to the negative 8. This is negative 35v minus 56. Question 3. The monomial in front of the parentheses gets multiplied to the first term and then to the second term. So writing that out, the 2x gets multiplied to the negative 2x, and then the 2x gets multiplied to the negative 3. This is negative 4x squared minus 6x. Question 4. The monomial gets multiplied to both terms. Negative 4 times v is negative 4v, and negative 4 times 1 is negative 4. Question 5. The structure changes. Here we have a polynomial. Specifically, it's a binomial. It's a polynomial with two terms, and it's being multiplied by another binomial. In the center, multiplication. A binomial times a binomial is done by performing the distributive property twice. The acronym for this process is called FOIL. Multiply the first terms in each parentheses, multiply the outer terms, multiply the inner terms, and multiply the last terms in each parentheses. Let's do this. The first terms, the 2n and the 6n. Multiply those together. 2 times 6 is 12, and n times n is n to the second power. Okay, now we're going to multiply the outer terms. The 2n and the 1. 2n times 1 is positive 2n. This is equivalent to doing the distributive property and taking the 2n and multiplying it to both things in the second parentheses. Okay, now in FOIL, the letter I, the inner terms, the ones in the center of the structure, that's the 2 and the 6n. 2 times 6n is 12n. Now the letter L in FOIL, the last terms, the last things in each parentheses. That's the 2 and the 1. Times those together. 2 times 1 is 2. When you do FOIL and you multiply the first, the outer, the inner, and the last, that will always produce 4 terms. Sometimes you can do combining like terms to simplify the answer. And in the case of this one, the 2n and the 12n are like terms and can be combined. The answer is 12n squared plus 14n plus 2. Now number 6, what is the structure? You've got to recognize the structure. You have to recognize that it's a binomial times a binomial. because when you recognize that, then you can know to do FOIL as your rule. So first, the 4n times the 2n, that's 8n squared. Now the outer, the 4n times the 6, that's 24n. Now the inner, the 1 and the 2n, that's 2n. And now the last, the 1 with the 6, that's 6. Are there any like terms? Those two are like terms. So the answer is 8n squared plus 26n plus 6. Now number 7, we have a binomial being multiplied to a binomial. This is done with FOIL, first, outer, inner, last. So x times the 6x is 6x squared. X again, but times to the negative 2 is negative 2x. Now move to the inner terms, the ones that are in the center of the structure. The negative 3 times the 6x is negative 18x. And now last, the last number in the first parenthesis times the last number in the second parenthesis. Negative 3 times negative 2 is positive 6. These two can be combined. So the answer is 6x squared minus 20x plus 6. Number 8, use FOIL. 8p times 6p is 48p squared. 8p times 2 is 16p. Negative 2 times 6p is negative 12p. And negative 2 times positive 2 is negative 4. And then these two are like terms and can be combined. 48p squared plus 4p minus 4. Number 9, FOIL. 6p times 5p is 30p squared. 6p times the negative 8 is negative 48p. Now the 8 times the 5p, that's positive 40p. And the 8 times the negative 8, that's negative 64. And these two are like terms and can be combined. 30p squared minus 8p minus 64. Number 10, FOIL. 3m times 8m is 24m squared. 3m times the 7 is 21m. Negative 1 times the 8m is negative 8m. And negative 1 times the 7 is negative 7. These two combine. Final answer is 24m squared plus 13m minus 7. Okay, number 19. There's a binomial, and it's being multiplied by a polynomial. Specifically, this is a trinomial over here, a polynomial with 3 terms. This is done by extending FOIL, or extending the concept of distributing. Start with the first term. And just like FOIL, where you would multiply by both things in the parentheses, multiply by all 3 things in the parentheses. That is, distribute to here, distribute to here, and distribute to here. When you get done doing that, move over to this term and distribute it to all 3 of the things in the trinomial. So this is an extension of FOIL, or another way to think of it, it is the distributive property. So 4a times 6a squared is 24a cubed. 4a times negative a is negative 4a squared. 4a times 2 is positive 8a. Now move over to the 2. 2 times 6a squared is 12a squared. 2 times negative a is negative 2a. And 2 times 2 is positive 4. Now, just like FOIL, where some of the terms were like terms and can be combined, that happened here. So we have 24a cubed, and then for the a squared terms, positive 8a squared. For the a terms, positive 6a, and for the constant, plus 4. Finally, number 20. Same structure. It's a binomial times a trinomial. We're going to distribute and distribute. We need to do 6 multiplications. Okay, let's start with the 7k and multiply to k squared. That makes 7k to the third power. Now 7k multiplied to the negative 2k. That's negative 14k squared. Now 7k multiplied to the 7. That's positive 49k. Now let's move over to the negative 3 and do 3 multiplications. Negative 3 times k squared is negative 3k squared. Negative 3 times negative 2k is positive 6k. And negative 3 times 7 is negative 21. Now combine like terms. 7k cubed minus 17k squared plus 55k minus 21. This concludes the answer key for the review.